We are in our new unit of statistics, and so this set of notes is going to be talking about displaying quantitative data. Quantitative data is values that are actually numerical. There's different ways to actually display this quantitative data that we will be going over. So our first set of quantitative data is a dot plot. We also have the stem plots. You might also know them as stem and leaf plots. Then we have our histogram. Histogram. And then we have our box plots. So we will be going over all four of these in this set of notes on how to create them and what they're used for. So they all four of these actually do represent numerical data though. So let's go over our first one, dot plots. These are used for small data sets with a small range, so a small max and min. How to create a dot plot, we're going to draw and label a number line from the min to the max, and you're not going to be skipping any of those numbers. You want to make sure that you have, so if you see at the example down here, it looks like it's skipping numbers. It's really not. It's going from 0, this is 1, 2, 3, and then so on, 4, and then this is actually 5, and so on. You're going to draw that number line. Don't skip any numbers, making sure that you have the min and the max. The reason why we don't want to skip numbers is because we want to see if we don't have data in certain spaces that allows us to see that we were low in those numbers. Then you're going to place one dot per observation above its actual value. So if we have, like if we see on number 1, we had 1, 2, 3, 4, so you keep repeating the dots if you keep having more and more data. And then, so this is just an example right here. Of a dot plot right there. Make sure you guys are titling it as well. Then your stem plots, you're going to give, the stem plots are good for giving a quick picture of the shape of distribution while including the actual numerical values. The other reason why we'd use a stem plot is because you don't want to work, you wouldn't want to use a stem plot if you had a large data set. It's way too hard to be including all those values. We have other methods to use for that. So now you're going to actually create, or how we actually create a stem plot. Number 1, you're going to separate each observational value into a stem and leaf. So what I mean by that, if we have like 14 grams, your stem goes on the left side. We then draw, step 2 says to write the stems in a vertical column. So this is your vertical column. And then draw a vertical line, which is right here, and also represented right here. And then we're going to write on the right column, which is going to be our leaves. So, so that 14, this 1 with the line in the middle means 14. This 256, so you'd write 25, and then that'd be 256. If I wanted to represent like 257, we would write a 7 over here as well. Okay? So then yes, the right side ends up being on the table, so it's not a vertical column, it ends up being a row. And then, for example, we could even do decimals. So this is kind of like the key of your actual stem and leaf plot that you're going to be telling us. And then this would be 32.9, so making that vertical line the decimal right there. Okay, so then we want to make sure that we write each leaf to the right of its stem. Make sure that you guys wrote down the image. I want you to at least draw this as your example, as well as this stem and leaf plot, which is right here. This is that single stem and leaf plot that we're going to be going over. So right here, if we actually read this number would be 20, this would be 31, and then so on. These two numbers would be like 69 or 67, 61, and so on. Okay, so then we are going to actually see a double stem plot. This time you always read from the center first. So make sure you are always reading from the center first. Okay, so for example, this number would be a 68. This number would be an 86. So we can go both directions. So we're saying that the pulse rate before we actually did any activity was a bit much lower. And then as we did an actual activity, it started to increase. We start seeing more values on the higher ends of the heart rate versus the lower ends over there. For a histogram, you're going to break the range of data values into classes and display the count or percentages of observations that fall into each of the classes. So how to actually create this, you are going to do step one, you're going to divide the range of data into equal width of classes. So equal width class means like I am going right here. I make sure you guys write down this histogram. It's talking about frequency and the age. So my range between here is between 20 and 30. My next range would be between 30, 40, 40, 50, and so on. So that's what I mean by the width of classes. So here I'm going between 20, 30. Then you're going to count the observational in each class, or that's the frequency. So like how many people are between the ages of 20 and 30. Well, in this case, there happen to be 2. So that's what I mean by the frequency, how many people. Then you're going to draw the bars to represent the class's height and the frequency. And in this case, our bars touch. In a bar graph, an actual bar graph, your bars would not touch because you're talking about categorical data and it's completely different categories. Here, we're talking about one thing, age, and one thing, frequency. The next thing that you guys want to make sure on your bar graph is that you have your axes labeled here. You should also have a title above here. So we could just say age of class. I don't know, maybe you're doing a college class. And then so you have your title, you have your axes labeled, you have your values here also labeled. Make sure that these bars are connected, they are actually touching. And then you would go up for your frequency. Then we calculate our another next value. Who's between the age 30 and 40? Well, there happen to be 4 people at that age. 2 here, 4 here, 5 here. So you're just adding the frequencies of these actual number of people who are between this age. Okay? So on the last one, this is our box and whiskers. This is also known as the 5-number summary. The 5-number summary includes the min, a quartile 1, the median, also known as the quartile 2, quartile 3, and the max. So this is your 5-number summary. This box and whisker provides a reasonably complete description of the center and spread of the distribution. That's going to be important very soon. Your quartiles 1 and quartile 3, also look like this, represent the 25th and 75th percentiles because we can categorize the data into quarters. So just think of a dollar. If you break it into quarters, you have 25 cents, then 50 cents, then 75 cents, and then a dollar. That's what we're going to be breaking our box and whiskers into as well. So let's look to see how we actually create this. Number one, you're going to order your data from min to max. It has to be in from least to greatest. Then number two, you're going to determine the median of that quartile, or the quartile 2. If you get 2 numbers as your median, make sure you take the average of those. And then your first quartile is the median of the bottom half of the data. We'll be going over all of these examples on the next slide. The third quartile, quartile 3, is the median of the top half of your data. So that's how this is actually try and practice this. So how to create our box and whisker plot. Let's go ahead and make sure our values are from our min to our max, and it looks like we are going from decreasing all the way to increasing. So good, we have that set up. So now we did that first step. Now we have to determine the median of our data. So I like just going through and crossing these out so I can find the median. You guys can also count in if you want to. So then I see that I actually have just one data value. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Awesome. I have the same amount on both ends. So this is my median or my quartile 2. Either name, I'm okay with whatever you want to do. Now we need to determine our quartile 1. We determine our quartile 1 by identifying the median again, but only of this lower half. Since we only have one number right here, we don't count the 26. If we had 2 numbers, we would count it. I'll show you that example on the next one. So I'm going to go ahead and cross out our data just like I found the median on there. Oh, look, we have 2 numbers. I'm going to add those up because we have to find the median or the average of it, so which is 46, and then divide by 2 because there's 2 values there, which is actually 23. So this is our quartile 1 being 23. Our min was 19. our median was 26, and then now I need to determine the quartile 3, which is the median of the upper half. So I'm going to go through. I have two numbers again. 29 plus 30 is 59. Divide that by 2 would actually be 29.5. So we have 29.5, and then we have our max at 32. So if you see, we have our 5-number summary. Okay, so I'm going to show you guys how. I'm going to do one more example of just identifying this again, and then I'll show you how to make the actual box and whisker plot with that example. So for this one, we want to make sure our first step that we have our numbers from least to greatest. So it looks like here we do. This is my min, this is my max, and then now we need to determine the median. So we're going to go ahead and start crossing out those values and go through and see that we end up getting our two values. So there's 4 on each side. Alright, so now we're here. So right now we have our 76 plus 82, and we are going to go through, we have to find the average of those. So to find the average, we do 76 plus 82, which is 158. Then we're dividing it by 2, the two values we just added together, which equals a 79. This is our median, or our Q2. Then we need to determine our quartile 1 and our quartile 3. So this is what I was saying, is that if we are given two values, we now have to actually include the 76. We got to cross that out. Now I'm left with one number as my Q1, which is 74. Then we're going to do the same thing. I have to include this 82 on this end in order to get my quartile 3, which is 91. Okay, so now we have all of our data values. I'm going to write them on the next page, just so that we can actually go ahead and create our box and whisker plot by using the 5-number summary. So, oops, sorry, maybe I'll be doing it here. Okay, so our min, we're going to go ahead and make a number line. We have to make a number line, and we can use intervals. Let me actually make this a little bit lower. So I see that my lowest number is a 45. So I'm going to count by, let's just say 5s, and then go up to my highest number is 98, but you have to have nice intervals. So we're going to say 100. So now I'm going to go up to 50, 55, 60, 65, 70, 75, 80, 85, 90, squeezing 95 in there. Okay, so now we're going to go ahead and actually plot this stuff. So what I mean by plotting, we're just going to make an actual bar where these values are. So starting off with our min, then our quartile 1's at 74, so it's a little bit before that 75. Then we have our median, which was 79, and then our quartile 3, which is 91, and then our max, which was 98. Pretty close to the 100. So we see that we have our 5 lines representing our 5-number summary. Well, we're going to go from our outside, that's your first whisker, then the 3 inner values there is actually your box, and then we're going to finish it with our last whisker there. The next thing that we want to make sure is that we actually have a title for this so we know what we're talking about. So we're going to say that this was test scores, and you can just write it below the number line, because then we know that those numbers actually represent the test scores. Okay, so the last thing I want to talk to you guys about is the actual percentages. So again, we're going to bring up the 25, 50, 75, and 100. So the 50% of your data, 25% of your data lies between your min and your quartile 1. Then we have another 25% of your data that lies between your quartile 1 and your quartile 2. Another 25% of your data lies between your quartile 2 and quartile 3. And then your last 25% of your data lies between your quartile 3 and your max. So what I mean by that, so when I'm going to be asking you guys questions, if you take the median, remember that the median is half of your data, which is your quartile 2. So between your min and your quartile 2, 50% of your data lies there. Between quartile 2 and your max, there's also 50% of your data. Then, when we got our quartile 1, we took the other half of just the lower half of our data. Well, if you break that 50% off already into another half, that equals our 25%. That's why we break these into quarters, making it our quartiles. All right, you guys, so just to recap, we went over how to make a box and whisker, how to make a stem and leaf, how to make a dot plot, how to make a histogram, and I think that was all 4 of them. So dot plots, histograms, stem and leaf, and our I keep forgetting histograms. Histograms, dot plots, stem leaf, and box and whisker. Okay, so and then we also want to make sure you know what quantitative data is. That is our numerical data. So all 4 of these will represent our data, and this will help you guys to start being able to display your data.